also have our design team here. We have Jeremy Medeiros from Howell Engineering and Ed Clarkoff from Clarkoff Design and Planning. So here's the plan for the evening. I'm going to give you a little background on the project, and the design team will talk about their design for the bridge. And finally, you'll be invited to visit 3 stations around the room to find out more about the project, and it's an opportunity to ask questions. If you haven't already, I'd appreciate it if you would sign in at some point. There's a clipboard in the back of the room, and take an index card. If there are any questions that you have or any comments you wish to make that aren't addressed at this meeting, please fill it out. And if you would like a personal response, be sure to include some contact information on the card. Okay, so after 15 years, the Newtown Creek Pedestrian Bridge project is finally becoming a reality. In November 2024, Newtown Township, Newtown Borough, and the Newtown Creek Coalition received a $1 million state grant to fund the design and construction of the Newtown Creek Pedestrian Bridge. The project is expected to be completed in 2027. The Newtown Creek Pedestrian Bridge project includes installation of a new bridge spanning the creek between Frost Lane in the borough and Sycamore Street in the township, next to the historic foundations of the old Newtown trolley bridge. It will provide safe pedestrian and bicycling circulation between the residential and business districts of Newtown Borough and Newtown Township. Currently, the closest safe pedestrian crossing to this area is at Jefferson Street, about a quarter of a mile away. Educational signage will draw attention to the historic Newtown Trolley Bridge, illustrating the role this area has played in the history of transportation systems and commercial development of Bucks County. The historic bridge piers supported a rail bridge for the trolley line connecting Bristol and Doylestown from 1895 to 1923. The bridge that we're building will supply a missing link in the extensive trail systems of Newtown Township, Bucks County, and southeastern Pennsylvania, enhancing access to recreational areas in both municipalities and beyond for both residents and visitors. So support for the pedestrian bicycle bridge crossings over Newtown Creek and better connections with the Newtown Trail has been building since the Newtown Creek Coalition hosted public visioning sessions in 2009, 2010, 2011, and 2012. Need for pedestrian crossings, especially in this location, were recommended in multiple planning documents of both municipalities, beginning in 2009 with the Newtown Area Joint Comprehensive Plan, and most recently in Newtown Borough's 2022 Comprehensive Plan Update and the 2022 Open Space and Connectivity Plan, and the 2024 Newtown Area Joint Comprehensive Plan Update. Planning for the proposed bridge began in earnest in 2021 with the support of the governing bodies of both Newtown Borough, Newtown Township, and the Bucks County Planning Commission. The Newtown Creek Pedestrian Bridge project is a joint project between Newtown Township, Newtown Borough, and the Newtown Creek Coalition. This is a unique partnership between 2 municipalities and a Pennsylvania nonprofit organization. The Newtown Creek Coalition was founded in 2006 and provides technical assistance to municipalities and other organizations applying for grants to protect and improve Newtown Creek. Its role with the Pedestrian Bridge project has been to facilitate the partnership, develop community support for the project, and to help obtain funding. We need to give thanks to a number of people. To State Representative Perry Warren and State Senator Steve Santaciero, thank you for your indispensable assistance in obtaining the grant for this project. Second, thank you to the adjacent property owners in the borough and township who graciously granted easements without which this project could not have gone forward. That's Scott Miller, Cliveden Estates Home, HOA, Alan Smith and the Sycamore Street Associates, and DLCP LLC. So we are now entering the design phase. This is where you, the public, come in. After you listen to our design team describe their thought processes and present their ideas, you are invited to visit the stations around the room to discuss the project in more detail and ask your questions. If you have any questions, as I said before, if you have any questions or comments for the team that were not answered this evening, please write them on the index cards and drop them in the box at the back of the room as you leave. And if you would like a personal response, please be sure to include your contact information. Okay.
Are these slides available online?
Not directly, no. Was there anything particular you wanted from them?
Just thought it'd be interesting to look at them.
Look at them again? We can see about getting information to you.
Thank you.
Okay. All right, so now I'm going to hand this over to Jeremy. Yes. Wait a minute, you want this in?
Yes, it is. Okay. So my name is Jeremy Medeiros with Howell Engineering. I am a professional engineer with, I guess, going on 29 years of experience, primarily in civil land development and in structural engineering. Recently, I've been focusing more on structural projects, which include being the engineer of record for the Culverdale Railroad in between Boyertown and Pottstown for, I believe, 8-9 years. And also working on the construction of a rail trestle bridge out in Elizabethtown. And like I indicated, that's under construction right now. And we, Hal, the team of Hal, at Thurkoff and Associates and Richard Grubb, we submitted a response proposal to, in response to the RFP, and thankful that we have an opportunity to work on this project. Basically, our task is to achieve the general goal, which is making a connection between North Sycamore and North State Street, or Edgeboro, at the locations that Judith had talked about. We also have the historic aspect of the project. This is just another photograph of the trolley bridge, which now we have the remnants of the stone piers. So our project is making that connection, but also making a path and a bridge that complement. We're not trying to recreate this original bridge. We're trying to complement that bridge with the designs we're putting together. So a lot of what we're doing right now is we're working within a number of constraints. So we have both horizontal constraints and vertical constraints. Our horizontal constraints are the tie-in points that were previously established here at North Sycamore and here at North State, Edgeboro, and Frost. So we have those two hard constraints. We have the secondary constraints of an easement that's been established, working down to what is a paper street. So basically established right away without construction of the street. That right of way, that paper street right of way, is divided into a northern section and a southern section. So our horizontal constraints here are within the easement. We enter the Paper Street, the northerly portion of the Paper Street right away across the creek, and then move down into the southerly portion of the Paper Street right away to make the connection to North State Street. We also, another constraint more solid than our easements and right-of-way are the existing piers. The original concept for the bridge and path took the bridge basically at the same angle to the north of those piers. What we've done in our initial planning was move the bridge to the north to basically hug that northerly edge of the Paper Street right-of-way. And the intention there is to provide as much separation between the bridge and those existing piers to prevent any use from jumping from the new bridge to the old piers. Second to that also is
They wouldn't do that, would they?
with a separation, a greater separation between the bridge and the piers, you have a better visual aspect. You're up on the bridge, you're looking down. Instead of having to bend over the rail to look down at the piers, you have a better direct sight of visual to the existing piers. So our bridge, we're going to sweep across, basically, like I said, hugging that northerly portion of the Paper Street right away. When we get across the bridge, and I'll talk about the floodplain situation in a second here, we're going to make this direct curve down towards into that southerly section of the right of way. Sorry about that. We're making a curve down from the northerly section of the Paper Street right of way, and we're really threading a needle here between this existing outfall channel and a group of significant trees in this area. So once we get through that tight area, we're going to basically then take a straight line down and hug the southerly portion of the right of way to our terminus point here with North State. And the location, the exact location of our tying point with North State is somewhat driven by an existing inlet that ties into our outfall channel here. So we want to be between that right-of-way line and between that inlet. So that's driving our location of our tying point there. So the floodplain boundaries are both horizontal and vertical. And within the floodplain boundary, we're dealing with both the outer 100-year floodplain, which hopefully you can see this fairly well here. We have boards that we can look at later that will be give you a better visual of those boundaries. But the westerly boundary of the 100-year floodplain is basically here. Easterly boundary is a little bit wider, separated from the stream over here. Inside the 100-year floodplain is what they call the floodway. And that's this inside line here, and then we have the inside line that comes down here. Now what the floodway is it's a portion of the 100-year floodplain where there is active flood. So the 100-year storms coming through, the water coming down that channel that's actively flowing is within that floodway boundary. The areas between the floodway and the outer boundary of the 100-year floodplain is more slack water. So our goal with our bridge configuration is to respect that floodway as much as we can. Obviously, we're going to have impact to both the floodplain and the floodway, but within the floodway, our impact is going to be limited to our piers. So, like I said, they're both vertical and horizontal. So we talked about our tying points, we talked about easements, we talked about the Paper Street right-of-way and the existing piers. This bottom visual just gives a blow up. Okay. Bottom visual just gives a blow up of the bridge configuration. This is a better look at the outer floodplain, the floodway. We have the existing piers. We have the floodway and then the floodplain. I guess one thing to note too is you see the separation between the edge of the stream and the floodway on the west side, and you see the edge of the stream and the separation between the floodway on this side. And that's part and parcel to the topography. If you would walk down to the stream here, it would be a steeper slope from this point down, which constrains the floodway, where here on this side of the stream is more of a gentle slope. And ostensibly, the floodway on this side and the floodway on that side, and the floodplain, they should be at the same elevation from a hydraulic standpoint. Water across this whole cross section is going to be at the same elevation. And that elevation is what we will discuss here on the next slide. Okay, so the top is basically the same graphic that we were looking at before. What I've done is put together a conceptual profile of both the pathway and the bridge. I know it's probably pretty hard to see, but like I said, when we set up our individual stations, you're going to better view of this. But from a vertical standpoint, our constraints are, again, the tie-in points with Sycamore and State, and then we have the vertical constraints of the floodplain and the floodway. So, based on FEMA information, our floodplain depth is elevation 165. And on my profile here, I have that delineated with this blue hatching. Another vertical constraint that we have to consider is ADA accessibility. So we want the project to be accessible to everybody and sort of stay out of the weeds with respect to the federal guidelines for an accessible route. And those federal guidelines mandate that an accessible path have a slope of less than 5%. So coming off of North Sycamore, what we're going to do, and this profile starts here on the northerly side of the driveway entrance. So this station is basically right here. So we're coming off that, again, with the constraint that we have to tie into that point, so we're not going to raise or lower it. But we go 15, 20 feet flat, but then what we're looking to do is take a constant slope down to the bridge elevation. And the way it looks like now is this is going to be our constraint that helps determine exactly the vertical position of our bridge. So it's this slope here, and it's going to be the floodplain elevation here. So right now, the way I have this profile laid out is this slope is 4.9%. So we're basically right at the boundary. I didn't want to make it 5% because then if there's any sort of issue with construction, there's going to be variability in the way that they grade, the way that they lay the asphalt. You don't want to get too close to that 5% because you might have a situation where a portion of the pathway is greater than 5%, and a portion of the pathway may be a little bit less. So we'll give it there a little bit of factor of safety in terms of establishing this slope. But basically, like I said, we start out flat, come down to 4.9% slope. Sorry about that. And then we start at the bridge. So the start of the bridge on each side, I'll refer to as an abutment. So it's basically going to be a pier, but it's also going to retain soil on the upslope side. So in my profile here, the lighter green shading is fill. So the lighter dashed line below that green hatching is the existing grade, then we have the path proposed grade, and then in between the two is our fill areas. So we're looking to balance our ADA accessibility, our adherence to not impacting the floodplain, and minimizing the amount of material that we either have to take off the site or bring into the site. So these grades and this exact elevation may change a little bit, but those are, again, our sort of our three hard constraints. Tie-in points, ADA accessibility, and adherence to the floodplain. Right now, I have, with this profile, I have about 2 feet between the 100-year floodplain and the bottom of the stringers of the bridge. So the bridge will be configured, obviously you'll have the bridge deck. The bridge deck then sits on stringers, and then those stringers, and the stringers are basically like floor joists, big, heavy floor joists. The decking will basically be perpendicular to the walking path. The stringers will be parallel to the walking path, and then under those stringers, you'll have the piers which will be orientated perpendicularly to the walking path. We'll have, actually I never give a full count, but we'll have our abutments, then we'll have 1, 2, 3, 4, 5, 6, 7, 8 piers. So 2 abutments and 8 piers within the floodplain area. From my engineering experience, obviously we're going to be affecting that flood flow because we will be within the floodway in this area. We will be affecting that flood flow with our piers, but from my engineering experience doing many flood studies, I think we'll have a de minimis impact on the floodplain elevation. We have to. Elsewise, we would have to go through the township and the borough for either waivers or variances, but then we would also have to deal with the Pennsylvania DEP and possibly FEMA. So we'll have to stay below, the threshold is we have to maintain impact below a 1/10 of a foot or just a little bit over an inch. But I think that's doable. And from a flood force standpoint, these piers have been standing since
1895.
1895, so, sorry. So, those stone piers, dry stack stone piers have been standing for 130 years, 140 years. So, our piers, and we'll get into the configuration of those piers here in a minute. I'm confident that we can build a bridge that's going to withstand those flood flows and stand for another 140 years. Okay, so I went through horizontal and vertical constraints. So my next group of slides are my artistic renderings of the bridge and path layout. So this particular rendering is looking from North Sycamore, obviously an aerial view. So we're coming downhill with that 4.9% slope. We'll hit a level area here, and then go across the bridge at a level, and then curve down towards North State Street. So here you can see it's a pretty good representation of the separation between our bridge and the existing piers. This rendering is not reflective of site treatments in terms of fencing and vegetative screening and just general plantings that Ed's going to talk about. But it should give you the general idea of how things will look coming from North Sycamore Street. This view is, and relatively aerial view from North State, Edgeboro. So here's our intersection point with North State. We're relatively flat again against the southerly boundary of the paper street. We start to curve to the north in this area, and that is purposeful. We go back here. I forgot to mention two other horizontal constraints. The one horizontal constraint is that we do have sanitary sewer lines running through this corridor. And we do have sanitary manhole here and a sanitary manhole over here. So we are threading the needle again, coming through here. And then, I mentioned it briefly, but basically our curve down here is to thread the needle between the significant trees. Here, there's an existing shed and there's that drainage outfall. So that's the reasoning behind this horizontal alignment. So that's looking from North Sycamore, that is looking from North State. So again, bend to the north to avoid the trees and the drainage ditch, and then a curve back to the west to basically thread the needle those two sanitary manholes. More or less a drone or aerial view. Existing piers and the bridge. Now notice that the bridge does have a curve to the south, and that's purposeful. Again, we're trying to span that floodway, but we're also trying to thread the needle between the two sanitary manholes. So we need to get over that floodway before we put our abutment in and start retaining soil. So that's why our abutment is here, but again, to be able to take that sweep south, we're going to have a slight bend in the bridge. So like I said, aerial view, existing pier stream. This is looking to the southeast. So we see again the existing piers here, stream. We're not set on a rail yet, so what you see here is just a very generic placeholder. But that's an aspect that we'll be looking for some input from the public in terms of what sort of treatment you'd like to see there, along with having made a positive determination yet on the type of decking. I'm leaning towards just natural wood, but there may be an argument for composite decking. So this is looking north, basically standing in the stream looking north. You'll see right here, night blow-ups of this, but there's a person standing right there. So you can get an appreciation in terms of the elevation of the bridge, which will be about 7 or 8 feet above the stream elevation, the base flow stream elevation. Another view looking southeast. So here's your first real view in terms of what our piers are proposed to look like. And basically what I am proposing is that the base of our piers will be formed concrete. So we'll basically configure a shape, and that shape will be complementary to the shape of the original piers. Sort of triangular, but with points facing upstream and downstream. So they'll have a similar shape. The other idea is to have a concrete form line, which basically means that instead of just being flat concrete, they'll have a pattern that matches some sort of stone pattern. You want to stay away from trying to mimic these piers exactly, because if you can't match them exactly, then it's going to be sort of the uncanny valley. You look at our new concrete piers, you look at the original piers, they're going to be similar, but they're not going to be the same. So it's going to be, it would actually be detrimental from a historic setting to try to match them exactly. So what we want to do is we want to try to do something historically or period accurate, but that's just complementary and not, again, trying to exactly mimic. So it will be some sort of stone pattern, tinted to look like different shades of stone. You might have seen that on the newer PennDOT or turnpike bridges. They're starting to do more and more of the form-line concrete with the tints. So, and it can look pretty realistic. If you get right up close to it, you're going to be able to tell it's concrete, but from standing, like say at this visual, from this standpoint, it will be a pretty good match with, again, some sort of concrete. So on top of those piers, those concrete piers will be what are called beds. And I'm taking the inspiration for these timber bents from period, historically, same period railroad bridges, and I'm sure trolley bridges. Basically, it consists of a sill plate, which sits directly on the concrete pier. These will have 4 posts. Outer posts will be angled, inner posts will be straight up and down, and then you have a cap. And then on the cap will sit your stringers. Again, the stringers are like floor joists that are going to run parallel with your path of travel. Here again, you can see existing piers, but here you get a pretty good view of those the concrete, the form-line concrete piers and the timber bents. I just pulled this off the internet, but this is something from around a set of engineered drawings from more or less the same period, showing timber bents. So here are your posts. You see the outer posts are at an angle. On top of those posts is your sill plate, and then this group of timbers here are your stringers. We are not going to need 6 8x16 stringers. What I'm picturing is that we'll have probably 3 stringers across the 8-foot width, and that would be sufficient to, that's why I'm also leaning towards a real wood deck to get better load capacity. Those of you familiar with composite decking know that if you don't have your deck joists close enough, that you can get sagging in the composite material. Where if we use a 2x material, we can span. Just imagine these stringers being separated by, well, it's an 8-foot wide bridge, so we would have stringers on the outside and then one in the middle. So really, we're just trying to span a little over 3 feet with our 2x material, which is definitely doable from a structural standpoint. So that's the inspiration behind the piers, the base, form like concrete, and then our timber fence. And here's a more close-up view. You got the stream in the foreground. I have a guide here for reference. Concrete, form like concrete with some stained stone pattern, and then our timber bends. This doesn't really give any detail. I just have a triangular mass to represent the bridge deck. But if you would be underneath, you would see the 3 stringers and then the bottom of the deck planking. Now this, I tried to get a similar vantage point from the original. I didn't really achieve it, but it's sort of the same. But basically, you're seeing the westerly abutment here, and then the remnants of 3 piers, and then you have the easterly abutment which there's remnants of that easterly abutment also, so. But that's sort of the bridge, again, looking from that historical vantage point. Last thing I wanted to talk about was schedule. Julia said about finishing the project. We do have a hard end date of end of June 2027. So right now we're in the schematic design process. I think we're frankly further along than just coming up with the schematic design, and that's part and parcel to the work of Julia and myself in terms of working with CKS engineers and establishing general parameters. So we're not starting exactly from scratch. So then the next 3 months will basically be the design development, where we start to look at more fine details in terms of what kind of concrete floor we're going to use, what sort of form liner, what's the reinforcing, how are we going to construct these timber bents. Basically just doing structural analysis, getting a general idea of our materials, sort of honing in on what we want to do with the railing. Ed's going to be working on site aesthetics in terms of plantings and amenities. We'll have to choose some locations for interpretive signage, that kind of thing. So that's what we'll be doing for the next 3 months. Concurrently with that, we will also be going to DEP and the Bucks County Conservation District to start our initial conversations with them, basically saying, coming in, we're going to be looking to, we're going to have some impact on the floodplain, we're going to have some impact on the stream, we're going to have some impact on wetlands. We're going to need to do some sort of erosion sediment control for construction. So it's good to get that process started early. And we'll also have to go through the process of just coming into the township and the borough to present the project from their standpoint and just make sure that we're meeting all the codes that we need to meet with our project. So basically, from there, we go into construction documentation, which is putting together the final sets of plans. We'll have a pamphlet of specifications, which gives guidelines in terms of how the bridge and the pathway are to be constructed, what exact materials we want to use. We'll have all the environmental permits and mandates to ensure that the contractor is following those permits. And that construction documentation will be what is put out for bid. So then we have a period of advertisement, bid and award in March 2026, end of March 2026, and a notice to proceed at the end of March 2026. And then we're giving the contractor or contractors a year to do the construction, which is more than enough. For a capable contractor and his subcontractors, a year to do this project is more than enough. And then we just go through, once construction is complete, we go through the project closeout, which will be form work that we have to fill out, both for the state, county agencies, but then also we assume that we have form work to provide to the grantors of the money. So anyway, that's the project as it stands in a nutshell.